Hi everyone, so this is a run through of the second mock that you've done. So this first question is a kinetics question. So it says, a student carried out an experiment to determine the rate of decomposition of hydrogen peroxide into water and oxygen gas. The student used 100 centimetre cubed of a 1 mole per dm cubed solution of hydrogen peroxide at 298 Kelvin and measured the volume of oxygen collected. Curve R in each of the figures 1, 2 and 3 show how the total volume of oxygen collected changed with the time under these conditions. So they're asking you in these first three questions to draw a curve on the graph to show what would happen to the curve if we use slightly different conditions. And the conditions in the first question are 298 Kelvin, which is the same temperature, 100 centimetres cubed of a 2 mole per dm cubed solution of hydrogen peroxide. Now notice it was 1 mole per dm cubed before. There are 2 marks for each of these questions, and that's because there are 2 areas of the graph you need to focus on. First, the rate, i.e. how steep the beginning is, and second, how much gas will be formed, so where it will flatten out. Now here we're using a higher concentration, so our rate will be faster and therefore will start off steeper. And then we're also using a higher concentration in the same volume, which means we're going to be making a higher number of moles of products. The concentration, in fact, is double, and so we're going to make double the amount of product. So you must start off steep and then flatten off at the top line, because we are halfway up this graph, if you like, 2.5 points up, so therefore it will be 5 points up for a 2 mole per dm cubed solution. For the next question, it says draw a curve in figure 2 show how the total volume of oxygen collected will change with time if the experiment is repeated at 298 Kelvin, same temperature, 100 centimetres cubed, same volume, but 0.4 mole per dm cubed. Now here 0.4 is 2/5 of the 1 mole per dm cubed that it was before. And so this, if you split this up into fifths, it would be 1, 2, 3, 4, 5, and so it's going to flatten off at this first line, and it's also going to be slower. So our initial line will be shallower, and it will flatten off at the first line. This next one says that we got the original experiment, but it's just repeated at a higher temperature. Now, if we're only changing the temperature and not the concentration, we're going to make the same amount of product, just going to make it faster. Now, what I would suggest you do here is not draw it from this line, because if you go up too far and then come back down again because you realise you've gone too far, then you'll lose the mark, because this is not how it would look. So instead, I'll just try and delete that. So instead, what you need to do is I would start from the flat bit of line, come across, and then go down like so. If you've got a ruler or something flat, you can use even better. Then explain why the slope or gradients of the curve R decreases as time decreases. Now, as the reaction goes on, the amount of reactant you have is going to decrease because it's reacting, so the concentration of reactant will decrease. That means there's less chance of collision between reactant particles, and so the rate decreases as well. And that's why the curve flattens. The gradient of the curve is the rate of reaction. So if it's getting shallower, then the rate of reaction is getting slower. So the 2 marks here are saying reactant concentration decreases, and therefore rate of reaction decreases. Then we have this question which is slightly different. So the student discovered that hydrogen peroxide decomposes at a faster rate when a few drops of aqueous hydrogen bromide added to the solution. The student found on the internet that this decomposition is thought to proceed in 2 steps as shown in the following equations. There they are. And it says write an equation for the overall reaction. Now a lot of you got a bit confused here when it was actually quite a simple question. You just got to realise what you have to do. All you have to do essentially is add these 2 equations together, like you would if you're doing a redox reaction question and then cancelling out the electrons. But here, you're going to be cancelling out other things. You'll see that HBr is on the reactant side here, but the product side here. So in the overall reaction, you would not draw that, so that would cancel. Similarly, the HBrO would cancel because it's on one side of the equation here and the other side of the equation here. So overall, you have 2 hydrogen peroxides here, you have 2 waters and 1 oxygen. So the overall equation is going to be 2H2O2 goes to make 2H2O plus oxygen, and that's it. Then give one reason other than the increase in rate of reaction why a student was able to deduce that the hydrogen bromide plays a catalyst in this two-step reaction. Basically, the hydrogen bromide, which is this thing that I've crossed out, was regenerated in step 2, and that's all you have to write, or it's not used up. So HBr is not used up during reaction. Or you could say it's a reactant in step 1, a product in step 2, or you could say it's regenerated in step 2. Any of those configurations for this answer will be fine. And now we have a Hess's Law question, which a lot of you seem to like now, a lot of you getting this right. I'm going to go through it anyway, because there are a few silly mistakes made in this question. So it says methanol is an important fuel that can be synthesized from carbon dioxide. The table shows some standard enthalpies of formation. So formation enthalpies, your arrows are going to go up first, and you've got to basically work out the delta H for this reaction. Now here, there's no need to multiply these numbers, because you can see there's no number in front of the ones that will have numbers. Hydrogen is 0, so you can put that on already. And you just got to copy those numbers down correctly. I saw a couple of people not copying these numbers down here correctly, and therefore getting the answer wrong. I also saw some people misreading their own writing here when writing out the sum, and therefore getting it wrong. So you've got minus 394 on the carbon dioxide, you've got minus 201 on the methanol, and you've got minus 242 on the water. This one's going to have to swap round, so we're going to swap this one round and turn it into a positive. This one would also swap round as well, but it's 0 anyway, so you don't need to worry about that. And so delta H equals 394 minus 201 minus 242, which equals in the end minus 49 kilojoules per mole, but the units are not important here, you don't have to write them in. And then state why the standard enthalpy of formation for hydrogen gas is 0, always by definition. Don't start writing about the fact that it's already an element, therefore it can't be formed from its elements and all that. Just say by definition, and that covers all that already. Again, this question was done pretty well by most people, but I would like everyone to be getting 3 marks out of 3 for all these types of questions, just because they're so formulaic. And if you understand what's going on, then you should be getting 3 marks if you follow these simple rules. So here we've got a pressure question. So it says, state and explain what happens to the yield of methanol when the total pressure is increased in the synthesis. So remember, if we increase the pressure, it's going to shift the side where there's fewer moles. So here you've got 4 moles of gas anyway. So here you've got 4 moles of gas, and here you've got 2 moles of gas. So the effect on yield, so it's the yield of methanol, which is this. The effect on that yield is that it's going to increase because it's going to shift to the right. And your explanation, first state how many moles of gas are on each side. So there are 4 moles of gas on the left-hand side, and 2 moles on the right-hand side, and then you say the equilibrium, must be the word equilibrium, shifts to the right in order to oppose the increase in pressure. And you've got to make sure you say what it's opposing. Don't just say the change, you must say what that change is. And I saw that a few times when I was marking. You need to eradicate that. Next one is about temperature. So we've got the hydrogen required for the synthesis is formed when methane and steam in a Hess reaction. The equation for the reaction is shown below. State and explain what happens to the yield of hydrogen in this reaction when the temperature is increased. Here's the hydrogen. You can see from the delta H value that the forward reaction is endothermic. So the forward reaction makes the reaction get colder again. You're heating this up, and therefore it's going to shift in the forward direction, and so you're going to increase that yield of hydrogen. An explanation for temperature, first say what the forward reaction is. So forward reaction is endothermic, you know that from the positive enthalpy change, and therefore equilibrium shifts to the right in order to oppose increase in temperature. Again, saying what that change is, not just saying it to oppose the change. So now definition, state the meaning of the term carbon neutral. A lot of you kind of understand what this term means, but unfortunately the mark scheme is very specific as to what it wants for the carbon neutral, and it's always the same. There is no net or overall carbon, not carbon dioxide, carbon emissions to the atmosphere. So there are two parts of this that must be written. First part, no net carbon emissions. Second part, you must state that it's into the atmosphere. If you don't, you'll lose the mark. Write an equation for the complete combustion of methanol. A few of you didn't get the formula for methanol right, even though it's given to you here and it's given to you on the previous pages. Although you should really know what methanol is. So CH3OH plus oxygen. Whenever you burn something with carbon and hydrogen in, you're going to make carbon dioxide of its complete combustion, which is here, and water every time. Balance the waters first, so that's 2 because there's 4 hydrogens on this side and you need 4 on this side. There's 1 carbon, already 1 carbon there, so you've got 1, 2, 3, 4 oxygens here, already 1 here, so we need 3/2 oxygens to balance. Then it says the equation for the synthesis of methanol is shown below. Use this equation, your answer to part D2, to deduce an equation to represent the overall chemical change that occurs when methanol behaves as a carbon-neutral fuel. So all you need to do here is add these two equations together, because this is the process that you use to produce methanol, where you're using carbon dioxide, and this is the process where you're getting the energy back out of methanol, where you're making carbon dioxide. So you just add them together. So CO2 plus 3H2 goes to CH3OH plus H2O, and you got CH3OH plus 3/2O2 goes to make CO2 plus 2H2O. And you just add them together, so you're going to cancel the things that can cancel. So carbon dioxide's on both sides when you add this together. So's the methanol. And so you cancel the methanol as well. And overall, you'll get 3H2 plus 3/2O2, and that makes your 3 waters, and that's the answer. And then we've got an enthalpy change question, not Hess's law. This is where you're using Q equals mc delta T. So let's just read the whole question. So we've got a student carried out an experiment to determine the enthalpy change when a sample of methanol was burned. The student found the temperature of 140 grams of water increased by 7.5 degrees when 0.011 moles of methanol was burned in air, and the heat produced was used to warm the water. And use those results to calculate enthalpy change for 1 mole of methanol was burned. So, the first mark is for writing out Q equals mc delta T. And you've got to realise that M is the mass of the stuff that you're heating, so this is the mass of water, 140 grams. C is your specific heat capacity of water here, and delta T is your temperature change, which is 7.5. So this will equal 140 times C, 4.18, times 7.5. And that equals 4389. And the units for that, because your specific capacity is in joules per Kelvin per gram, you're timesing this by Kelvin, because an increase in centigrade is the same as an increase in Kelvin, and by grams, you're left with joules. So this is not in kilojoules, this is in joules. So you divide this by 1,000 to give you this in kilojoules. Now that's not the end of this, because remember an enthalpy change is in kilojoules per mole. So you've got your kilojoules, now you just have to work it out per mole. So, and per mole means basically dividing by moles. So to get your delta H, you're going to do 4.389 divided by number of moles, which is 0.011, which I've got from the question here. Don't have to work out number of moles, it's given to me. If it gave me a mass of methanol, then I would have to work out moles by doing mass over MR, but I don't here. And this gives me an answer of 399. That's not finished because this is an exothermic reaction. The temperature increased. So I make this negative 399. And again, the units don't really matter. You don't have to write them in the end. It's the number that's important. This balancing question, you kind of just got to get. And it's 2, 15, 15, 6. I would always leave a balancing question until the end and come back to it. It's not worth wasting a lot of time when section B is usually somewhere where you run out of time. Sorry, so I'd come back to these at the end. Just leave them, even if you want to spend 30 seconds on it, that's the most. Don't dwell on them. Next question is oxidation states. Remember, any element by itself, P4 is an element. It's not joined to anything else. It'll have an oxidation state of 0. Because, remember, your oxidation states have to add up to the charge on the molecule. The charge on this is 0. So the only value that P could have to have 4 times whatever it is equaling 0 is 0. And then your H2PO4, remember, oxygens are generally always -2. So that's going to be -8 overall because there's 4 of them. You've got +3 from the hydrogen because each one of those is +1. And then to make this equal 0, you've got to have +5 from the phosphorus. So this is +5. And if you're going to do working, I'll do it off the line because you want to write your answer on the line so there's not other numbers there to confuse the examiner or at least not give them any excuse to not give you the mark. This next question, mass spectrometry question. So fertilizer grade phosphoric acid is manufactured from sulfuric acid and calcium phosphate. Use the following precise relative atomic mass data to show how mass spectrometry can be used to distinguish between pure sulfuric acid and pure phosphoric acid, which both have an MR of 98 to 2 significant figures. So all you have to do here is basically prove, by adding these numbers together, that they have different MRs to 5 decimal places. So for sulfuric acid, you've got H2SO4 equals 2 times 1.00794 plus the S, which is 32.06550, plus the 4 oxygens, which is 4 times 15.99491, and that equals 98.06102. And then your H3PO4, you do exactly the same. So you got 3 times 1.00794 plus 30.97376 plus 4 times 15.99491, and that gives me 97.9772. You must get these numbers right to get that mark. So make sure you type these into your calculator carefully, and make sure you check this at the end when you've done the rest of the questions. It's only worth 1 mark, so it's not worth wasting loads of time checking it over straight away. Come back to it at the end, but make sure you check these, as I would check the other numbers that you calculate as well, over and over again if you have time, just to make sure they're right. Now, this next question stumped a few of you because you're getting mixed up between stating the meaning of the term catalyst and how a catalyst works. So if it says explain how a catalyst works, or explain how a catalyst does its jobs without explaining, then you go into the alternative route, low activation energy and all that. If it says explain the meaning, that basically means define what a catalyst is. And so here you're going to say that a catalyst is a substance that increases rate of reaction without being used up. Now, I prefer you to use this term without being used up, rather than saying without being chemically changed at the end, because it's very easy to forget that at the end bit. And a catalyst is chemically changed during a reaction. It's just during that chemical change it gets changed back into what it was originally. So not being chemically changed during the reaction is not true, but it is not chemically changed at the end. But I'd rather you just use this simple phrase because it's much more difficult to get wrong. State the meaning of the term hydration. Well, hydration is the addition of water. And this is different from saying adding water, because addition is a mechanism. So this basically means the electrophilic addition of water, which isn't the same as saying adding water to something. You could add water to something, there could be no reaction. This is actually stating what that type of reaction is. So addition of water is hydration, and that's something you could learn. And then write an equation for the hydration of propene to form isopropyl alcohol. Give the IUPAC name for isopropyl alcohol. So first, when you're writing the formula of isopropyl alcohol, it's given to you up here. So make sure you read the whole question again if you think you're missing something you should have. So isopropyl alcohol you had to draw out structurally, because if you just drew out the molecular formula of it, then it could be ambiguous. So isopropyl alcohol is CH3, CHOH, CH3, and that is formed from C3H6 plus H2O. So that's your first mark. IUPAC name, this OH group is on the second carbon, and so this is propan-2-ol. Next question, this is about metal extraction. Metals can be extracted by different methods. Give one reason why titanium cannot be extracted directly from titanium 4 oxide using carbon. So this is all about your titanium carbide being formed. So you can say titanium carbide formed, which makes the product brittle, or the product is brittle, something like that. Most of you got that right. I think you know what to write there. And then this is a slight twist on the metal extraction questions, but they always give you what you need in order to answer the questions if you're not expected to know it. So here, titanium steel is an alloy of titanium iron. Titanium steel is extracted from mineral ilmenite, FeTiO3, in a two-stage process. Purified FeTiO3 is first converted into a mixture of two metal chlorides. These two metal chlorides are then reduced simultaneously using sodium. So first is to write an equation. So they've given you FeTiO3, and it tells you reacting with chlorine and carbon. So you're going to add chlorine, which is Cl2, and carbon, which is just C by itself, and that forms your iron 3 chloride, which it gives you the formula for. There's no excuse for getting that wrong. So it's FeCl3, and titanium 4 chloride, which is what is formed in this extraction of titanium. So you need to know that formula for the equations for titanium, and it's TiCl4. Then you must balance. There's 7 chlorines on this right-hand side. Oh no, you haven't finished yet, sorry, there's also carbon monoxide formed, how could I forget? So plus CO. So there's 7 chlorines on this side, so you need 7 over 2 Cl2s, and then you need 3 carbons to get rid of those 3 oxygens to form 3 carbon monoxides. Then it says write an equation for the simultaneous reduction mixture of iron 3 chloride and titanium 4 chloride to form iron and titanium. So you've got iron 3 chloride from before, you should know titanium 4 chloride. That's reacting with sodium, and that makes iron, titanium, and sodium chloride, which is NaCl. You need 7 NAs to get rid of those 7 Cls that are on this side to make 7 NaCls. Scrap iron is used to extract copper from dilute aqueous solutions containing copper 2 ions. Explain in terms of redox what happens to the copper 2 ions in extraction. So the copper 2 ions gain electrons, or gain 2 electrons, and are reduced. That's your 2 marks. Remember, oil rig, the gain of electrons is reductions, they are reduced. If you wrote copper gains electrons, that is incorrect. Copper is made, the copper 2 ions gain electrons. Then aluminium is an expensive metal because it's extracted from molten aluminium oxide, using electrolysis. Write the half equation for the reaction that occurs with positive electrolysis extraction. So the positive electrode will attract the negative ion, and the negative ion in aluminium oxide is oxide, which is O2 minus, which goes to form oxygen O2. You need 2 of those to balance, and then balance electrons, so 4E minus. So this next question on group 2. It says there are many uses for the compounds of barium. Write an equation for the reaction of barium with water. So barium with just liquid water is going to make barium hydroxide, and with steam it will make barium oxide. So it's barium plus water, and you've got to remember that the hydroxides of group 2s have 2 hydroxides for each metal. So it's BaOH in brackets 2 plus hydrogen, and you'll need 2 waters in order to do that. State the trend in reactivity with water of the group 2 metals from Mg to Ba. It increases. A few of you are talking about solubility and things like that. It asks for the reactivity with water. So just say it increases. It gets more reactive down the group, just like the alkali metals. And then give the formula of the least soluble hydroxide of the group 2 metals from Mg to Ba. Now, a lot of you realised that the metal that forms the least soluble hydroxide is magnesium, because the hydroxides increase in solubility down the group. But it asks for the formula of the hydroxides. You have to write MgOH2. And then state how barium sulfate is used in medicine. Explain why this use is possible given that solutions containing barium ions are poisonous. So the uses of barium meal. If you talked about use for x-rays of the gut, things like that, then that's fine. But just the words barium meal would get you the marks. Then explanation, too many of you said it is insoluble. I've said this many times that you must be really clear with your answers. And if you're using the word it or they and not being specific about what you're actually talking about, you're risking losing the marks. So you've got to say the barium sulfate is insoluble. And that's it, that'll get you the second mark. Next one was a free radical substitution question. So chloromethane such as dichloromethane and trichloromethane are produced in industry as they have many uses. Trichloromethane has been used in the manufacture of the refrigerant chloro-difluoromethane, and chlorine can react to dichloromethane to form this. So write an equation for each of the following steps and the mechanism for this reaction. So first step is the initiation step. So that is the chlorine splitting apart. So your Cl2 turns into 2Cl dot. And the first propagation step is your Cl dot reacting with your other reactant. So it's CH2Cl2. And this grabs a hydrogen to make HCl and then leaves behind CHCl2. Remember, your atoms must balance on both sides of this. It's still an equation, so your chlorines you must have 3 of. 1, 2, 3, 1, 2, 3. And your hydrogens, there must be 2 on both sides. 1, 2, 1, 2. And your carbons just 1. So make sure they always balance. And then finally, your second propagation step needs to reform that chlorine free radical. So you've got the free radical that you've just formed, CHCl2 dot, reacting with a chlorine to make CHCl3 plus Cl dot. And then give one essential condition for this reaction, name the type of mechanism. You need UV light for that initiation step. That's what breaks apart the chlorine, and the mechanism is called free radical substitution. A few of you are writing free radical chain mechanism. That is incorrect. Free radical substitution is what you should be writing. Then an organic product, X with MR of 154 is obtained when chlorine with acid trichloromethane. Write an equation for this. So you've got trichloromethane, which you should get the formula for from the previous page, plus chlorine, and this is just going to substitute further to make CCl4. Now you can always check that it has an MR of 154, it does, and then you also make HCl. So this is the overall equation, but you could have free radical substitution equations if you needed to for that. And then it says the following infrared spectrum was obtained for a sample of X produced in this reaction. Use this infrared spectrum to explain why it's possible to deduce that the sample of X contains no trichloromethane. A lot of you were pointing out that this peak was for a carbon-carbon bond and one of them had a carbon-carbon bond, the other one didn't, or they didn't have a carbon-carbon bond. That is irrelevant because neither of them have a carbon-carbon bond, so you can't use that to distinguish between them because neither of them have it. It's like saying that neither of them have an OH peak. You know, they're not going to, they don't have OH. So you've got to think about what the difference is between them, and the difference between trichloromethane and X, which is tetrachloromethane, is that trichloromethane has a CH bond, and that's what the first mark is for, recognising that is true. So trichloromethane contains or has a CH bond, first mark. Second mark, CH produces a peak at, I think it's 2850 to 3300, and this is missing from the spectrum, and therefore the sample can't contain any trichloromethane because there are no CH bonds of a sample, if you like. But that's what will get you the 2 marks for that question. And then here, explain with the aid of equations and the intermediates that form an ozone layer why the European Union has banned the use of chloro-difluoromethane as a refrigerant. So, this is the important thing, the aid of equations. Some of you just weren't writing equations. So, initiation step, it's not chlorine breaking apart, it's the CFC that breaks apart, so it's CHCF2 goes to make CHF2 dot plus Cl dot, and then it's that chlorine free radical which will react with the ozone in reaction in 2 formulas that you could just learn. So this is the first one, and this is the second one, the ClO dot reacting with another O3 to form 2O2 plus Cl dot and regenerating it, and then it's the overall reaction they want last, so 2O3 goes to make 3O2. There is your 4 marks, 1, 2, 3, 4. And then the compound 2333 tetrafluoropropene is the refrigerant used in all new car air conditioners. Draw it. So you've got 3 carbons, it's propene. Propene's a double bond, doesn't matter which side you put it, but I put it on that first one. And then you could just draw in the bonds that you got to fill. So remember, each carbon has to make 4 bonds, no more, no less. Remember, the first carbon is going to be the one attached to this double bond, because you always name the functional group first. So the 2333 will be this one, this one, this one, and this one. And so those are your Fs for fluorine, and then these 2 gaps are going to be Hs to fill in the gaps. And then give one reason why this compound here is a more environmentally acceptable refrigerant than chlorodichloromethane. It won't cause chlorine free radicals because it does not contain chlorine. Alkenes are useful intermediates in the synthesis of organic compounds and complete the elimination reaction by drawing appropriate curly arrows. It's nice to draw this out for you already. So the curly arrows, this OH, I'll just zoom in on this actually because I might not be able to draw it as accurately as I'd want to. So this OH grabs an H that is on the carbon next to the carbon with the bromine on, because then the carbon-hydrogen bond will break and move between the 2 carbons to form a double bond, and then this bromine will leave, like so. And then the next question, draw structures for the EZ isomers hexthreene. So hexthreene has a double bond in the middle, and remember that E means that the 2 groups will be on opposite sides. And so you can have CH2, CH3 on the one side, and CH2, CH3 on the other side, like that, so with H's here and here. This is hexthreene because you've got 1, 2, 3, 4, 5, 6 in a row, and the double bond starts on the 1, 2, 3rd carbon. And you've got to draw the same thing, but Z means same side, and so you will draw them on the same side, like so. There we are. And then state the meaning of the term stereoisomers. There are many different types of stereoisomerism. EZ is not the only type, so it's not asking you what EZ stereoisomerism is. It's asking you what to define it, and so it's the same structural formula, and it's important you remember that. The same structural formula, but different arrangement of atoms in space. And then another mechanism. So the equation for the first reaction, the conversion of hexarine into hexanthreol, sorry, is shown below. There it is. So you've got, I would again draw out all the bonds. I'm not going to draw the H's in, but you should. And then you've got H2SO4, so the structure of this you need to learn. And it looks like this. 2 double bond O's, 2 OH's. This will come out and grab the top H, and the OH bond will break, and the electrons go onto the oxygen. That forms a negatively charged oxygen on that, and so what you'll get is the following molecule, 6 carbons in a row. The H will go onto one of these carbons that did have a double bond, but in this case it doesn't actually matter which one it is because they're both as stable as each other. And so you've got a positive charge on this carbon, or the other one, and then you've got your, zoom down a little bit, then you've got your OS, double bond O, OH, negative charge on the O, and then a lone pair comes out and attacks that positive charge. Sorry, you should have an H on the other carbon that didn't get the positive charge earlier. Then it all gets a bit wordy for section B. So, the reaction of butane 1,4-diol with butane dioic acid produces the polymers PBS used in biodegradable packaging and disposable cutlery. Butane dioic acid is produced by 2 different processes. First process, aqueous sodium hydroxide reacts with the 1,4-dimebutane to make butane 1,4-diol, and butane 1,4-diol is oxidized to butane dioic acid. And then process 2, glucose reacts with carbon dioxide in the presence of a microorganism to produce butane dioic acid directly. The carbon dioxide uses the process obtained from a local factory that produces bioethanol. So, safety says to deduce one safety reason, one environmental reason why process 2 is preferred. So safety, the sodium hydroxide is where you should focus here. So sodium hydroxide used in process 1 is corrosive. And then environmental, process 2 can act as a carbon sink because it's taking in carbon dioxide that would otherwise have been released into the atmosphere by the factory. And you can sum that up by just saying it's a carbon sink. It's like absorbing carbon, if you like. But you don't use that phrase. Carbon sink is the phrase you would use. Another mechanism. So name and outline a mechanism for the following reaction that occurs in process 1. So you've got C, 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 Br, Br, and then I'm not going to draw all the H's in, again, as I always say you should. And then it's not NaOH, you've got to get rid of the Na, it's just OH minus, lone pair, comes on, attacks the C, and that bond breaks and goes on to the Br. No need to draw the products because they're already drawn for you here, and the name of this is nucleophilic substitution. And then we come to a infrared spectra question. So the infrared spectra shown are those of these compounds. Now, here they're not giving you the structure of them, but you've got to work out what they have in terms of functional group from the names. So no need to draw them all out because the names kind of show you what the functional groups are. So 1,4-dimebutane kind of has nothing. It's an alkane. Doesn't really have a functional group. It has some halogens on it, which you can't really look for in an infrared spectrum. Butane 1,4-diol is an alcohol. So you're going to have an alcohol OH, and butane dioic acid is a carboxylic acid. So you're going to have an acidic OH, but also a cedal bond O peak. So let's first look for the alcohol OH peak. That comes about 3,300 if you look in your data table, and is quite rounded. And if you look down these three spectra, you'll see that is this one here. You see that's at 3,300, and this is a very characteristic look to an OH peak. So that one is your second one, so that's B. And then we're going to look for the cedal bond O peak, it comes at about 1,700 and usually goes quite low. In this case though, if you look at the two spectra, you can see quite clearly that it's here, but there's not one here. So this is your cedal bond O peak. Not as low as it usually is, but it's still pretty low. And so that is your butane dioic acid, and then the other one must be A. And then a production of alcohol question. So in the production of bioethanol, glucose C6H12O6 is converted into dilute aqueous solution of ethanol and carbon dioxide. Given name this process, take 3 essential conditions necessary to produce a good yield of ethanol. These are on a flashcard. Just got a copy of the flashcard ready. It's called fermentation. And you need yeast. You need a warm temperature, but not too warm. I always remember body temperature as your temperature, 37 degrees, because that's our enzymes work best at 37 degrees, so the enzyme in yeast will work okay at that temperature. And you need an absence of oxygen. Don't write air, write oxygen. If there was oxygen there, then you'd form ethanoic acid rather than ethanol. So we need an absence of oxygen for that to happen, for ethanol to be produced rather than ethanoic acid. And then class the state of alcohols to which diol butane 1,4-diol belongs. So butane 1,4-diol is 4 carbons, but then the OHs are on the 2, 1 and 4 carbons, so the ends. So the fact it's on the end carbon means there must be a primary alcohol. You can also see that it tells you when this is oxidized, it forms butane dioic acid, which is a carboxylic acid. Primary alcohols, when fully oxidized, form a carboxylic acid. So that's 2 different bits of evidence you can use to suggest that. To do this, you need acidified, and that's the word that people generally forget, acidified potassium dichromate. And the equation here, a bit long-winded, so butane 1,4-diol has the structural formula of this: HO, CH2, 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 CH2OH, and then you use square brackets O to represent the oxidizing agent, and that will make your carboxylic acid, which is given to you up there, plus water. And you can see you've added 2 oxygens, but first balance the hydrogens. So on this side you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here you've got 1, 2, 3, 4, 5, 6. So you'll need 2 waters in order to balance hydrogens, and therefore you've only got 1, 2 oxygens here, and 1, 2, 3, 4, 5, 6 here. So you need another 4 oxygens, so you'll put a 4 in front of that oxidizing agent. The student investigated the chemistry of the halogens and the halide ions. In the first 2 tests, the student made the following observations. So in test 1, he added chlorine water to aqueous potassium iodide solution, and the colourless solution turned a brown colour. And then test 2, add silver nitrate solution to aqueous potassium chloride solution. The colourless solution produced a white precipitate. So the first test, a lot of you put that iodine was the brown colour, but remember after the reaction, a lot of you put iodide as the brown colour, but if a lot of you got the ionic equation right by writing the following: I minus plus Cl2 goes to make I2 plus Cl minus. You need 2 Cl minuses and 2 I minuses to balance. You can see the product is this. It's not iodide, that's a reactant. Iodine is one of the products, so that is the species responsible for the brown colour. State the type of reaction, displacement or redox would be fine. Either or. Remember, the chlorine is displacing the iodine. It's also a redox reaction because the iodine is getting oxidized to iodide is getting oxidized to iodine, and the chlorine is getting reduced to chloride. And then name the species responsible for the white precipitate. Test 2. Again, a lot of you are saying that it was chlorine that was responsible. It's not. The white precipitate is silver chloride, and it asks you to name it. So it wasn't good enough just to write the formula. Write the simplest ionic equation, that's the silver, Ag+, adding to the chloride, Cl-, to make your AgCl, and then state will be observed when an excess of dilute ammonia solution is added to the white precipitate obtained in test 2. Dilute ammonia will dissolve the white precipitate, the AgCl, so white precipitate dissolves. Remember that concentrated ammonia will dissolve both silver chloride and silver bromide. Silver bromide won't dissolve in dilute ammonia, and silver iodide will not dissolve in either of them. Another couple of tests. In 2 further tests, the student made the following observations. So he added concentrated sulfuric acid to solid potassium chloride, and the white solid produced misty white fumes, which turned blue litmus paper to red, and added concentrated sulfuric acid to solid potassium iodide, and then a lot of stuff happened. The white solid turned black, gas was released, it smelled of rotten eggs, and a yellow solid was formed. So, write the simplest ionic equation for reaction that had taken place in test 3. The first thing to do really is probably to work out what misty white fumes were. They were HCl, and so the simplest ionic equation for this being formed is H plus Cl minus goes to make HCl. And then the student had read in a textbook that, I'll just explain ionic equations again. The ionic equations only writes the ions reacting together to make the product, not everything else. And then students had read in a textbook that the equation for the reaction test 4 was that. Right, the 2 half equations. Now from this reaction, you should be able to deduce what the reactant and product is for each half equation. So you first got I minus turning into I2, and then you've got H2SO4 turning into H2S. So let's balance the top one first. Balance anything that's not hydrogen or oxygen. So the I's, balance hydrogen, there's none of it, oxygen, there's none of it, and then charges. You need 2 electrons on the right-hand side to balance that 2 negative charges on the left. And then the bottom one, S is already balanced. Balance oxygens with water, we need 4 of them. Balance hydrogens, we've got 8, 10 on this side, already 2 on this side. So we need 8 hydrogens, and then balance the charge, we also need 8 electrons on the left-hand side. because this side has an overall charge of 0, this side had an overall charge of +8, so we need electrons, 8 of them, to balance that. State the role of sulfuric acid. So sulfuric acid gets reduced by the iodide ion, so therefore sulfuric acid is an oxidizing agent. And then finally, the yellow solid is sulfur. And then last question. The student knew that bromine can be used for killing microorganisms in swimming pool water. The following equilibrium is established when bromine is added to cold water. There it is. Use Le Chatelier's principle to explain why this equilibrium moves to the right when sodium hydroxide solution is added to a solution containing dissolved bromine. I saw a lot of people writing that you'd added some reactant to the left-hand side. It's important to realise that a reaction at equilibrium, everything is mixed together. You can't add to something or increase the pressure or change the temperature of just one side of the reaction. That's nonsensical. You can change the temperature or increase the pressure or decrease the pressure or add something to all of it, the whole mixture, but not just to one side. So if you're adding something to the reaction, either it will be a reactant or product, and in which case it will shift to get rid of it again, or if it's not a reactant or product, which sodium hydroxide is, the reason it will shift is because the sodium hydroxide, or whatever you're adding, will react with one of the reactants or products. In this case, sodium hydroxide is an alkali, and so it will react with the H plus ions, the acidic H plus ions. So the first mark is saying NaOH, or the OH minus, reacts with H plus. And that means the H plus are removed. So equilibrium will shift right to replace lost H plus. And that's enough for 2 marks. And the last bit is to deduce why bromine can be used for killing microorganisms in swimming pool water, even though bromine is toxic. Only small amounts are used. If a large amount of bromine was used, yes, it would be toxic to the swimmers, but only a small amount is used, and therefore the bromine is very dilute, and so it's not a problem. If you have any questions about any of those that I've been through, then please don't hesitate to email me. But I hope that helps, and I look forward to hopefully some better results in your 3rd mock and final mock.